Hello everyone, today we are going to start Maxima and Minima. So let's start our class. Maximum and minimum values of a function. Maximum and minimum values of a function. The definition of maximum. Let f of x be a function, and f of x be a function with domain D, proper subset R means real number. Then f of x is said to attain the maximum value at a point A belongs to D. A is the element of domain set. If f of x less than equal f of a for all x belongs to D. For all x belongs to D. In such a case, A is called the point of maximum, and f of a is known as the maximum value or the greatest value or the absolute maximum value of f of x. Remember that f of x be a function with domain D, proper subset R, then f of x is said to attain the maximum value at a point A belongs to D. D means domain set. If f of x less than equal f of a for all x belongs to D, in such a case A is called point of maximum and f of a is known as the maximum value or the greatest value or the absolute maximum value of f of x. Next, minimum. The definition of minimum. Let f of x be a function which domain D, proper subset R, then f of x is said to attain the minimum value attain the minimum value at a point A belongs to D if f of x greater than equal f of a for all x belongs to D. In such a case, the point A is called the point of minimum, and f of a is known as the minimum value, known as the minimum value or the list of value, minimum value or the least value or the absolute minimum value of f of x. Let f of x be a function with domain D, proper subset R. Then f of x is said to attain the minimum value at a point A belongs to D if f of x greater than equal f of a for all x belongs to D. In such a case, the point A is called the point of minimum and f of a is known as the minimum value or the least value or the absolute minimum value of f of x. Next, we'll discuss local minima and local maxima. Local minima, number 2, local maxima and local minima. Maxima. A function f of x is said to attain a local maximum at x equal to a if there exists a neighborhood a minus delta comma a plus delta of a such that f of x less than f of a for all x belongs to a minus delta comma a plus delta comma x is not equal to a, or f of x minus f of a less than 0 for all x belongs to a minus delta comma a plus delta comma x is not equal to a. In such a case, f of a is called the local maximum value of f of x at x equal to a. Remember, a function f of x is said to attain a local maximum at x equal to a if there exists a neighborhood a minus delta comma a plus delta of a such that f of x less than f of a for all x belongs to a minus delta comma a plus delta and x is not equal to a, or f of x minus f of a less than 0 for all x belongs to this and x is not equal to a. In such a case f of a is called local maximum value of f of x at x equal to a. Next, local minima. Local minimum. A function f of x is said to attain a local maximum or local minimum at x equal to a if there exists a neighborhood a minus delta comma a plus delta of such that f of x greater than f of a for all x belongs to a minus delta comma a plus delta comma x is not equal to a, or f of x minus f of a greater than 0 for all x belongs to a minus delta plus a plus delta comma x is not equal to a. The value of the function at x equal to a, that is f of a is called the local minimum. value of f of x of f of x at x equal to a. Next, first derivative test for local maxima and minima. First derivative test for local maxima or minima. Let f of x be a function differentiable at x equal to a. Then let f of x be a function differentiable at x equal to a. Then x equal to a is a point of local maximum or of f of x if Roman number 1 f dash a is equal to 0 and Roman number 2 f dash x f dash a is equal to 0 and Roman number 2 f dash x since sign from positive to negative, as x passes through a. That is f dash x greater than 0, that is f dash x greater than 0 at every point in the left neighborhood a minus lambda comma a of a. And f dash x less than 0 and f dash x less than 0 at every point in the right neighborhood a comma a plus delta of a. Remember, let f of x be a function differentiable at x equal to a. Then x equal to a is a point of local maximum of f of x if f dash a is equal to 0 and f dash x change sign from positive to negative as x passes through a, that is f dash is greater than 0 at every point in the left neighborhood a minus delta comma a of a and f dash x less than 0 at every point is the right neighborhood a comma a plus delta of a. x equal to a is a point of local minimum of f of x if Roman number 1 f dash a this equal to 0 and Roman number 2 f dash x since sign from negative to positive as x passes through a, that is f dash x less than 0 at every point in the left neighborhood a minus delta comma a of a, and f dash x greater than 0 at every point in the right neighborhood a comma a plus delta of a. If x equal to a is point of local maximum of f of x if Roman number 1 f dash a is equal to 0 and f dash x change sign from negative to positive. Remember, f dash x change sign from negative to positive as x passes through a, that is f dash x less than 0 at every point in the left neighborhood a minus delta comma a of a, and f dash x greater than 0 at every point in right neighborhood a comma a plus delta of a. See, if f dash a b is equal to 0 but f dash x means derivative of f of x does not change sign, that is f dash a has the same sign, f dash a has the same sign in the complete neighborhood of a, then a is called a is neither a point of local maximum nor a point of local minimum. Remember, if f dash a is equal to 0 but f dash x does not change sign, that is f dash a has the same sign in the complete neighborhood of a, then a is neither a point of local maximum nor a point of local minimum. Next, higher order derivative test. Higher order derivative test. Higher order derivative test. Let f be a differentiable function on an interval I, and let C be an interior point of I, such that Roman number 1, f dash c is equal to f double dash c is equal to f triple dash c. F double dash c, that means derivative of f of x at x equal to c, derivative of f double dash of c is equal to f triple dash of c. This equal to f n minus 1 of c. This equal to 0. And number 2, f to the power n of c exists is non-zero, then if n is event and f to the power n of c less than 0, this implies x equal to c is a point of local maximum. Number B, if n is event and f to the power n of c greater than 0, this implies x equal to c is a point of local minimum. Next, number C, if n is odd, this implies x equal to c is neither a point of local maximum or a point of local minimum. Nor a point of local minimum. Next, critical point. A point x equal to alpha is a critical point, of a function f of x if f dash alpha is equal to 0 or f dash alpha does not exist. A function may have a local maximum or local minimum at critical points. Remember, a point x equal to alpha is a critical point of a function f of x if f dash alpha is equal to 0 or f dash alpha does not exist. A function may have a local maximum or local minimum at critical points. Thank you.